Okay, in this video, let's talk about the division of two polynomials. Okay, so division. It's R4, part 6. Divide polynomials using long division. What is a long division? Long division is the following. Um, let's see, we do this long division by example. We follow the similar steps as we divide an integer by integer. This is cubed. So 3x cubed plus 4x squared plus x plus 7. We're going to divide, find the quotient, and the remainder. Okay, so we're going to do this computation. We divide this long polynomial by x squared plus 1. Okay, the quotient will be on top, the remainder will be on bottom. It's like what we did for the division of a integer. Okay, let me copy it in this clear place. So division is like the multiple choice, not multiple choice, not multiple choice. It's like the multiple try steps. So first, you always do the division between the leading terms. So this is a leading term. We're going to divide 3x cubed by x squared. Only do this division. When we do this division, we cancel x squared from top and bottom. You will get 3x. Okay? So divide the leading term by leading term only. You get 3x. You put it on top of x because they have the same degree. Okay, so you put 3x here and then you multiply this x squared plus 1 by 3x. There is no x term here, then there's no x squared term. After multiplication with 3x, there's no x squared term. So you skip this part. And 1 times a 3x is a 3x. Okay? So we always keep the terms with the same degree in the same column. If some terms is missing, some degree is missing, just skip it. Leave this blank. Okay. And then you do the subtraction. 3x cubed minus 3x cubed. This is 0. 4x squared minus, here is 0. So 4x squared minus nothing is 4x squared. X minus 3x, negative 2x. Be careful, it must be x minus 3x. It's a subtraction. And then you move this 7 down. Okay, so this is one step. And now you check, this degree is 2, this degree is also 2. It's greater than or equal to the degree of the denominator. So we continue this division. So we divide the leading term by leading term again. We only do this for every step. Okay, so it's equal to 4. 4x squared over x squared is 4. So you put 4 here plus 4. 4 it has a degree 0. 7 has degree 0, so you put it on top of 7. And then you do multiplication. 4x squared. And there's no x term, so you skip this part. And times 1 plus 4. Okay, so 4x squared minus 4x squared, 0. Negative 2x minus nothing, negative 2x. 7 minus 4, 3. Okay. At this step, negative 2x, it has degree 1. This denominator has degree 2. So this degree is less than it. Then you stop. Okay? So you stop at this moment. So the quotient is, this part is a quotient, 3x plus 4. The remainder is negative 2x plus 3. Okay, so this is a long division. Long division can help you to do whatever division between two polynomials. Okay, and the polynomial inside is called the dividend, and then the polynomial outside, that's a denominator. Technically, this is the denominator, this is numerator. It's called the divisor, and the quotient remainder. Okay. Now let's check another one. Let's use a different page. I need to write everything on one page, so. Assume we're doing the similar thing, but we change the pair of the two polynomials. This time, the dividend is x to 4 minus 3x cubed, and okay, so two polynomial. Let me write it here. We have this pair. This first polynomial is divided by the second one. The difference between this example and the previous example is that in this dividend polynomial, there is no x squared term. There's no x squared term. In the long division, you must have x squared term. It is missing because it has coefficient 0. So you must put a term here. In the textbook, they just leave a blank. Leave the blank. I don't know if you can understand what it is or not. So I always put a 0x squared here to let you know there is a x squared term here. So you can leave it as a blank. It doesn't matter. You either leave it blank or you write it like me, put a 0x squared here. So you do not miss any power. So x4, 3, 2, 1, 0. If you have a fifth power, it will be 5, 4, 3, 2, 1, 0. Okay? And the divisor. The divisor has missing term. It's not that important. The first one has a missing term x. X term is missing, but it's okay because when you do the division, you will artificially you will leave blank here. But here you will see that when you put a blank on top, it's kind of weird. When you leave blank on bottom, it's not that difficult. Okay, anyway, let's try. We put a 0x squared here. Then we do the same step. We divide x to 4 by x squared. Once again, we only divide the leading term by the leading term. The quotient is x squared. This can be done quickly. It's not that difficult. Okay, so x squared has a degree 2, so it's on top of x squared here. And then let's check. X squared times everything, so you got x to 4 minus x cubed and plus x squared. And you do subtraction term by term. X to 4 minus x to 4, 0. Negative 3x cubed minus negative x cubed. Okay, negative 2x cubed. 0 minus x squared. 0x squared minus x squared. And you copy one term down. You can copy two, it doesn't matter. You will not use this part. Okay, so this is the first step, and be careful, there's a 0 minus 1. And then you divide the leading term by leading term, so you get a negative 2x cubed over x squared is negative 2x. Negative 2x. So negative 2x times x squared. Negative 2x times negative x. Negative 2x times 1. Right? Yeah. Let's try subtraction, term by term. Okay, this is a 0. This one, negative x squared minus x squared is negative 2x squared. 2x minus, be careful, there's always subtraction. 2x minus negative 2x is 4x. Negative 5. And then you continue. Negative 2x squared. How do I get negative 2x squared? The leading term, this is leading term, over x squared is equal to negative 2. Okay. Is equal to negative 2. So negative 2 times everything. So negative 2 times x squared. Negative 2 times negative x. Negative 2 times 1. So this is 0. 4x minus 2x is 2x. Negative 5 minus negative 2, negative 3. Hold on. Yeah. Once again, I make my stupid mistake. Okay, this part is 2. 2x, negative 2x times x is plus 2x. So this part becomes a 3. Okay, this step is right. And then this is a 3. Here is negative 3. Okay, so this is a 3, and 3. This becomes x, this becomes minus 2. The quotient is x squared minus 2x minus 3. The remainder is this x minus 2. Okay, so I make mistake again. Oh, I don't know why. Here I do, when I do multiplication, it's a negative 2x times negative x. It's supposed to be 2 plus 2x squared, not just x squared. I miss this coefficient 2. Here I don't. Here I did it. I only missed it here. Well, my bad. My bad. Sorry. Okay, be careful. It's not difficult. Just be careful. Don't do the similar thing like what I did. Okay, so that's a quotient and remainder. And once again, in the textbook, they leave blank here. Leave a blank, you should understand it as 0. 0 minus x squared is negative x squared. Okay? So if you don't leave blank, you just put a 0x squared here to remind you this is 0, this is 1. Okay. And in the textbook, they put the this from the beginning. They start to write this x squared from the beginning. But when I learned this long division, I write them on top of the corresponding positions. But this position also does not matter. So you can write from the beginning, or you can write on top of each corresponding degrees. There's for this part, there's no standard way to write it. Okay, so that's a long division. Long division, once again, be careful. You see here, I make a mistake. Okay, so we already studied the polynomial. We know the degree, leading term, leading coefficient, coefficients, and we know the addition, subtraction, multiplication, and the division. Division, we have this long division. Okay, this is a long division, and then let's talk about the polynomial with two variables. What is a polynomial? The polynomial we discussed has only one variable x. Possibly this polynomial may have two variables. What is a polynomial of two variables? First, monomial in two variables. A monomial in two variables, x and y, this time y also becomes a variable, has a form ax to n, y to m, ax to n, y to m. Okay, so a is a constant, n and m are non-negative integers. Non-negative integers. And the degree is n plus m. Okay, this time if you have two variables, they form a product, then the degree is the sum of those two powers. Okay, so let's see, for example, if you have a monomial in two variables with degree 2. Degree 2, you will have ax squared or axy or ay squared. Okay, so they have three forms. If you have degree 3, you will see that ax cubed, ax squared y, axy squared, ay cubed. Those four possible ways. Actually, if you check here, you see it's very familiar. Why? This is a monomial. If you put a monomial together, you will get polynomial. And remember, in the computation part, we have x minus y, x squared, xy, y squared is x cubed minus y cubed, and x plus y, x squared minus xy plus y squared is x squared, x cubed plus y cubed. So technically, this is the all possible monomials with degree 2. This is also all possible monomials with degree 2. This part, it contains a monomial of degree 2. This has a monomial of degree 1. When you do product, you get a degree 3. Okay, so that's the connection. Technically, you have monomial degree 1, monomial degree 2. You get I'm sorry, not monomial. Polynomial of degree 1, polynomial degree 2, pure degree 2, pure degree 1. Then the product is pure degree 3. Right? Okay. And when we have polynomial, we actually do the similar thing like we did for the Euro polynomial of degree 1 with one variable. For example, we can do addition, subtraction, multiplication, and we don't discuss division because division is more complex. Okay, so we can do addition, subtraction, multiplication. Addition, subtraction, multiplication. No division, no division. And among them, the multiplication is the most complex one, but still, it follows away. What is a multiplication? FOIL. Remember that word, FOIL. But if you don't remember, first, outer, inner, last. I think it's a word. But anyway, I never use this word. I just do this term by term. 2x, 2x, 4x squared. 2x, y, 2x, y. Negative y, 2x, 2x, y. Negative y, y squared. And combine them, it's a 4x squared minus 4xy plus y squared. Okay, just term by term multiplication. And also, actually, for this one, we have that formula. Remember that formula. A minus b squared is a squared minus 2ab plus b squared. You let a be 2x, b be y, you will get the same thing. Okay? So that is the discussion of a polynomial with two variables. You can have polynomial with two variables, three variables, four variables, whatever number of variables. It doesn't matter. Okay? But for our study, we focus on the polynomials with just one variable, the simplest case. Okay? Okay, so this is division. The division has long division. That's a standard and universal method. And sometimes when we have some special case, we have another special division. It's called the syntactic division. It only works in the special case. This section is section R.6, not R.5. I think I put R.5 in the Bosquejo. It's wrong. Sorry, it's R.6. Syntactic division is used to divide a polynomial by x minus c, just this special case. We only divide arbitrary, this polynomial can be anything. We divide this arbitrary polynomial by x minus c. We will use example to demonstrate how we get the syntactic division. Okay? So let's see the example. Our polynomial is 2x cubed minus x squared. There's no x term. I put 0x and plus 3. Okay, so we're going to divide this dividend by x minus 3. This moment we didn't introduce the syntactic division. Let's still use the long division. Let's check out what is going on. Okay, so let's do the long division. We divide 2x cubed, leading term by leading term. We get 2x squared. And we multiply this by 2x squared. We get 2x cubed minus 6x. Okay? So this term is 0, disappear. This term is negative x cubed, x squared minus negative 6x is plus. So it's a plus 6x squared. So it's a 5x squared. And we move this 0 down. Actually, you can move everything down, right? You move 0x and plus 3. Okay, then we divide 5x squared by x. Leading term by leading term, you got 5x. So 5x times negative 3, negative 15x. This part is 0. This part is 0 minus 15, it's negative 15, it's 15x plus 3. And then you copy this, you divide this 15 x by x. So it's plus 15. Plus 15. 15, you get 15x. This is minus 45. You do subtraction, it's 48. 3 minus negative 45 is 3 plus 45 is 48. 48. Okay, so let's check. Let me use it. You see here, by this method, the first term always cancel. So this term is not necessary to write. This term is not necessary to write. And this term is not necessary to write. Okay, so you don't need them. You only have this 5x squared, and you only have 15x, and you have 48. Okay, and also we put everything in the order. So this is constant term, this is x term, this is x squared term, this is x cubed term, always, because you have a highest power is x cubed. So we going to do the following. I'm going to rewrite it, okay? How do I rewrite it? I do it following step. So I put a 2 here instead of a 2x cubed. Then minus x squared, we put a negative 1. The coefficient of x squared is negative 1. X has coefficient of 0. The constant term is 3. So then minus x minus 3. And this term, because it's repeated, I'm not going to copy it. I only copy negative 6. After I copy negative 6, you see here, you will get 5. Negative 1 minus negative 6 is 5. 5, you move this term 0 down, right? Here, remember, you move this 0 down. And this 5, and you get 15. How do you get this 15? 15 is 5 times a negative 3. You get 15. And how do you get negative 6? Negative 3 times 2, you get negative 6. Okay? So 0 minus 15 is positive 15. Positive 15. And the positive 15, how do you get next part? 3 times 15. Sorry, this part. 3 times 15, not that 3. The 3 times 15, negative 3 times 15 is negative 45. And 3 minus negative 45 is 48. Okay, so how do I do it? I get this 2. 2 is not used, but 2 times negative 3, I get negative 6. Okay, and I do subtraction. You get 5. 5 times negative 3, I get negative 15. And 0 times minus negative 15 is 15. And 15 times negative 3, I get negative 45. And 3 minus negative 45 is 48. Okay, so that's the way how I get it. I continue to simplify it. 2, negative 1, 0, 3. Sorry. You get 2 here, you get 5 here, you get 15 here. And 48 is the remainder. 48 is the remainder. Okay. Because that's the last one. That's the last one. It stops. So 2, 5, 15. They come from here, here, and here. Okay. Let me rewrite it again. So first you have 2. 2 times negative 3. You get negative 6. Right? Negative 6. Negative 1 minus negative 6 is 5. 5 times negative 3 is negative 15. 0 minus negative 15 is 15. And negative 3 times 15 is negative 45. It's a subtraction, you get 48. And this number 2 is moved down. You don't do anything, you just move it down, copy it down. Okay, so this is almost done. They're almost done. Almost, not always, almost. We always do subtraction, but for many moments we always forget that this is subtraction, and we have this minus because it's a subtraction with a 3. It's a negative 3, so you always have minus sign. So in order to, you have minus sign, you have subtraction, you repeat it, you see minus and negative is plus. So instead of have minus sign, we are going to do the following. This is the final version. 2, negative 1, 0, 3, x minus 3. So first you move this 2 down. And then 2 times 3 minus, it's a part of the formula. Remember? Okay, so this moment we consider this negative sign as a part of a formula. This is x minus c. So c is 3. 2 minus 3, you get 6. Okay, I got 2, sorry, not 2 minus 3. 2 times 3 is 6. Negative 1 plus 6 is 5. And 5 times 3, 15. 0 plus 15 is 15. 15 times 3 is 45. 3 plus 45 is 48. Okay, so this is all 3 terms are the coefficients of a quotient, and this is a remainder. So the quotient is the constant linear term and the square term, and the remainder is 48. Okay, so this is a syntactic division. This is the correct version formula. It's a formula. Okay, keep in mind this negative sign is part of the formula. We will do exercise. We will do exercise to find it. For example, we divide x cubed minus 4x squared minus 5 by x minus 3. Okay, so let's try the syntactic division. X cubed, coefficient of 1. X squared, coefficient negative 4. X, no x term, coefficient of 0. Constant term, negative 5. X minus 3, c is 3. Okay, so when you get c is a 3, if you want, you can mark it. This is a 3. Now let's check. First, you move this 1 down, and 1 times 3 is 3. So this is a product. 1 times 3 is 3. Negative 4 plus 3 is negative 1. And then negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times 3 is negative 9. Negative 5 plus negative 9, negative 14. Okay, the negative 14. So the quotient is, check here, constant term, x squared term. So it's x squared minus x minus 3. The remainder is negative 14. The remainder is negative 14. Okay, so that's it. That's it. Be careful, in the formula, it is x minus c. It's a special part of this syntactic division. And sometimes you have to be careful, really be careful. divide 2x5, 5x4, negative 2x3, 2x2, 2x, and 3 by x plus 3. Why they always choose this number 3? Okay, by x plus 3. Be very, very careful here. X plus 3 is x minus negative 3. So C is negative 3. This is a crucial point in this computation. Okay, now let's check. 2, 5, negative 2. Because you see here, 5, 4, 3, 2, 1, 0. There's no missing term, so just copy the coefficients. 2, negative 2, and 3. They are just numbers. You have 6 terms. And this is x minus negative 3. Be careful. I always circle it. This is C. Okay, now let's compute. Hold this. That part is useless. So you copy 2 down. 2 times negative 3, negative 6. 5 plus negative 6, negative 1. Negative 1 times negative 3 is a 3. Negative 2 plus 3 is a 1. 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. Then this is a positive 3. It's positive 1. This is negative 3. 0. Okay? Okay? So the constant first, second, third, fourth. The quotient is okay. I do that counting because I want to determine the degree of the quotient. This is the coefficient of constant term, degree of the linear term, square term, cube term, fourth term. So it's a 2x to 4 minus x cubed plus x squared minus x plus 1. Okay, they are the coefficients only. You have to put the corresponding power function. The remainder is 0. And be careful about this. When you really do the syntactic division, it's better for you to just cover this x minus symbol. Then it's useless. You just use this negative 3 and do that product. And then do addition. Okay, let's do one more example about this syntactic division, and we will stop this video. One more. We try to divide, 3x 4 x 3 negative 3x and plus 1. X plus 1 over 3. Here it is x minus negative 1 over 3. Okay, you have to write this step. So you get x minus negative 1 over 3. And then you're going to copy the coefficients of the dividend here. It's a 3. The x squared term is missing. Be careful. 1, 0, negative 3, and a 1. X squared term is missing, so you have 0. Let's get the syntactic division. Okay, put a 3 here. And 3 times negative 1/3 is negative 1. 1 plus negative 1 is 0. 0 times negative 1/3 is 0. 0 plus 1 is 0. And this 1 times this is 0. Negative 3 plus 0 is negative 3. Negative 3 times negative 1/3 is 1. 1 plus 1 is 2. Right? So 3, negative 1, 0, 0, 0. Its addition is negative 3, 3. Negative 3 times negative 1/3 is positive 1. 1 plus 1 is 2. So the quotient is constant linear constant first, second, third. 3x cubed minus 3. The remainder is 2. In the book, I think they even don't write this part here. Write it or you don't write it. Okay, so this is a syntactic division. You just put C here, not put x minus C, just put C here. This is a syntactic division. Do practice. It is faster than the long division because in the long division you're going to write a lot of redundant symbols, so it takes a long time. But for the syntactic division, be careful. In the formula it is x minus C. So if you have x plus a number, you must write it as x minus negative of that number. Okay, so that's a crucial point. When you get this number, you copy it here. Don't copy this part. I should not copy it. You copy it here, and then you move the first term down, and do the product, put it here, and do addition. So in a syntactic division, it's a addition. It's addition. Okay. Okay. We finished this section. Then next, we are going to study the quadratic function and the properties. Technically, we repeatedly see this in the inequality of a quadratic equation, inequality involving quadratic functions. But here, this time, let's study it again. Okay. So next time we do the quadratic function and the properties. Good. We stop this video. Thank you.